Hey guys, Zong here, back with another math video. Today we're going to be conquering cryptarithms, and I'll spell that out. Cryptarithms. Yeah. You may be wondering, what is a cryptarithm? And you can just look at the problem, and you can probably just tell it's those things that you see on math competitions all the time. It's these things that take a heck of a long time because you have to guess and check and do all this stuff and solve for all these variables. And it can be quite hassling, and many people don't actually know of a real way to solve them. So we're going to review how to solve cryptarithms and the correct method of solving them. So to show this, let's just go through the thought process of this problem. So send more money. Send plus more equals more money, and I've written out the variables on the right. And just to make it easier, I've written out the numbers 0 through 9. Because variables have to be different numbers. So whenever we confirm that a variable is a certain number, we can cross it off the list to make sure we don't have another variable also equal that number. So let's get started. So when you look at this problem, you think, where the heck do I start? And really, the most important thought process is where you start with a cryptarithm, because that is, you know, you have to go from there. So d plus e equals y. They're all different variables. We don't know what to do with that. N plus r equals e plus o equals n. They're all different variables. What do I do with that? S plus m equals mo. So, okay, so the correct thing to do is, let's start from s plus m equals mo. Let's think about it this way. S plus m can either be less than 10 or greater than 10. If it's greater than or equal to 10, m has to be 1. And what do you mean m has to be 1? Well, if s plus m is less than 10, then there wouldn't be mo. It would only be o, because there would only be one digit, not mo. So it has to be greater than 10. Because if it was less than 10, it'd just be o here, and there wouldn't be m right here following m, because it wouldn't be greater than 10, it'd be less than 10. So if it's greater than 10, but it can't be 20, right? It can't be 20 or more, because two one digit numbers can't add up to 20, like more than 20, or even 20 itself, because 20 is 10 plus 10, or even 19, because 19 is 10 plus 9. It has to be either from 10 to 18. So knowing this, m has to be 1. I mean, think about it. Since it has to be greater than or equal to 10 and it's less than 20, well, the unit, like the digit in the tens place, has to be 1, right? So m is 1. And I hope you understand, because s plus m has to be greater than 10, or else there wouldn't be an m there, and it has to be less than 20, because one-digit integers can't add up to 20 or more, and thus m has to be equal to 1, because m is the number in the tens place. So if m is 1, we can cross off 1 off the list. Then let's think about it. So if m is 1 and s plus m has to be greater than 10, then if s is 8, then it's 9, right? And that's less than 10, and we only have one digit there, but it's not. So it has to be, since it's not 8, it has to be 9, right? Because it has to be 10 or more. It has to be 9. 9's the greatest one, the only one-digit integer that when added to 1 equals 10 or greater. So s has to be 9. We cross off 9 off the list. So m equals 1 and s equals 9. So what does that make o? Well, 9 plus 1 is 10, right? So 9 plus 1 is 10, so m is 1, and o has to be 0. I mean, after all, if s is 9 and m is 10, and as of 10, you bring the 10 down, of course, o is 0. Of course, you could go two paths from this. Actually, you could see if e plus o is greater than 10. If e plus o and these two are greater than 10, and you carry one, then o could be 9 plus 1 plus 1. Because if e plus o is greater than 10, then 1 would be carried over, and s plus m would have s plus m plus 1 would be the thing. But if that were the case, then 9 plus 1 plus 1 would be 11. And 11 would make mo 11, and m would be 1, and o would be 1. You can't have that because they're different numbers, they're different variables, and they can't be the same number. They can't be both 1. So what we know from this is that o has to be 0, and e plus o is less than 10. Although I don't really need to say that, because no one-digit number that adds to o actually can be greater than 10. So that's sort of unnecessary, but it's nice to just put out all the information we have up there. So what can e equal? And this is where it gets sort of weird. So e plus 0 is n. So you think E equals N, right? That's impossible. E and N are different numbers because they're different variables. And thus, we know that a 1 has to be carried from N plus R. So N plus R has to equal 0, be greater than 10, sorry, greater than or equal to 10. And why is this? Like, well, E can't be equal to N because they're different numbers, and O is 0. So the only way we can have this is if N plus R carries a 1 over and adds that to E to get N. So we know that N plus R is greater than or equal to 10, but we also know that N plus N equals E plus 1, which is a convenient thing to have. So knowing this information, we can't really find out E and N now. So let's go over a column. So N plus R equals E, and we know that N equals E plus 1. So E plus 1 plus R equals E. And actually, this isn't entirely true because you could have well, that's actually impossible because E plus 1 plus R equals E, and since R is always positive, it has to be E plus 1 plus R equals E plus 10. Because again, you could carry over you can carry over 1, and so yeah, so if it does carry over 1, because E can't actually equal, E can't actually equal itself if 1 and R are positive, so it has to carry over 1. So so let's try some things. Let's play around, try to see what we can find. So theoretically, you think that 1 plus R then would have to be 10, right? R plus 1 equals 10, and you'd probably think that R is 9. And you wouldn't be that bad of a thinker if you thought that, but that's actually not the case, because you have to consider, what if D plus E is greater than 10 or greater than or equal to 10, and then basically you'd have to carry over another one, and then change into E plus 1 plus 1 plus R equals E plus 10. So let's put that over here. E plus 1 plus 1 plus R equals E plus 10, and you cross them out, and then R would equal 8. And again, we add the extra 1 because D and E can be greater than 10. If they're greater than 10, you have to carry a 1, right? So if they're greater than 10, you have to carry a 1 over. So R can either equal 9 or R can either equal 8. But wait a sec. How can R equal 9? S is already 9, right? S is already 9. R can't equal 9. If S is already 9, S is already taken 9. So you can take this out, and R has to equal 8. And then we get some more information. If R equals 8, then D plus E has to be greater than 10 because it carries 1. So D plus E greater than or equal to 10. And what does this tell us? What does this tell us? It tells us, for one thing, okay, we have this information. We know that 8 is crossed off. We know that R equals 8, and it's just getting to be too much information to comprehend in our minds. So let's just try to put down all the information we have in another equation. So let's put S 9 1. So E is, we don't know E yet. We know this is 0 1 0, and N, and then N is N, and then R is 8 E, and then D E Y. Okay, so you have this information. We have D plus E has to be greater than or equal to 10. N equals E plus 1, and you have this information. Now where do we go from here? It gets sort of weird. Basically, you've already crossed off a bunch of numbers, and now it just comes down to guess and check. And let me show you how to do this. So N equals E plus 1, right? And the numbers we have available are 2 through 7. And if N equals E plus 1, then N has to be 3 or greater, and E has to be 2 or greater. So let's start with E equals 2. So E equals 2, N equals 3. And just looking at this, so if E is 2, N is 3, so carry over 1. So N is 3, right? N is 3, so if N is 3 and you carry over something from D and E, N is 3, so 3 plus 8 plus 1, the thing you carried over from DE, is of course going to be 12, which makes sense because you carry over 1 from here. Then you get E. E is 12, E is 2. So it seems to work. So it seems to work out, right? But then you have to consider the last column. D plus E equals Y, and we know that D plus E is greater than 10, greater than or equal to 10. So it has to. So Y has to be. So 2 and 3 are off the list, right? Because we just took them. So 2 and 3 are off the list, and D plus E has to be greater than or equal to 10. And E is 2. D can only be 9 or 8. And if D is 9 or 8, first of all, 9 and 8 are already both taken, and that's the only way you can get it greater than 2. So can't be. So since D can't be 9 or 8 to make D plus E greater than or equal to 10, then E equals 2 is off the list. And if we try E equals 3, then if we try E equals 3, then it's the same logic. D plus E has to be greater than or equal to 10. And if E is 3, then the only numbers D can be is 7, 8, or 9. Wait a sec, can't D be 7? If D is 7, let's say that, because it's not taken yet. If D is 7, then 7 plus 3 equals 10. And what would that make Y? Well, Y would equal 0. And 0 is taken by O, right? So that can't be it either. So what if E is 4? Well, now D can be either 9, 8, 7, or 6. So let's try 7 again. So if E is 4 and that adds to 7, well, 4 plus 7 equals 11. And Y can't be 1 either, because 1's already taken as well. Well, what if D is 6? That's the same thing. 4 plus 6 is 10, and Y would equal 0. So E can't be 4 either. Now E equals 5. Let's try E equals 5. If E equals 5, then D could equal, let's say, D could equal 9, 8, 7, 6, or 5. So let's try 7, because 7, 7's still not taken. So E plus 5 is 7. Then 7 plus 5 equals 12, and Y would equal 12. I mean 2, sorry, Y would equal 2. And if Y equals 2, sorry, it's getting a bit messy. If Y equals 2, then 2 is not taken. It used to be taken when we were guessing and checking for E equals 2, but now it's not taken because E is 5, and that means N would equal 6. And D would equal 7, because we tried 7. 7 plus 5 is 12. So D would equal 7. And does this work out? Well, it looks like it does. 2 isn't taken, 5 isn't taken, 6 isn't taken, 7 isn't taken. I think we have a winner. So let's just try it out to confirm, to check that it works. And I'll do that now. So okay, so N would equal 6, 5. R would equal, what did we say? R was 8, yes. And Y would equal 2. Okay, does this work? Let's see if it works. So send. And it's really easy to check these because, oh, I forgot D. Silly me, I forgot D. D would equal 7. And send more. Uh, 6, 5, 2. Send more money. So that's what we have. And does this work out? It's really easy to check cryptarithms because you can just substitute them in and add them, which is a good thing. So does this work? So 7 plus 5 is 12, so carry the 1. 1 plus 6 plus 8 is 15, so carry the 1. 5 plus 1 is 6, don't carry any 1s. 9 plus 1 is 10. It works. So we have our solutions. This is our this is what we get. It's great. And hopefully you saw how we used like logical reasoning to get through most of it. And eventually at the end you might have to guess and check a little bit, but not too much if you already gotten most of the variables. And that's really the main method to solve cryptarithms. Really know where to start, know where to go from there, find out some variables, and try to use logical reasoning to guess out the rest. Thanks, and I hope you had a good time. Hey guys, Zong here, back with another math video. Today we're going to be tackling some coordinate geometry. So, look at the problem. I drew the graph out for you to make it a bit easier. So, look at the problem and try to solve it. Okay, time for the solution. So, this